Hi everyone. Solderless breadboards are great for building prototypes of circuits to see how they will work. But it can be a bit difficult trying to build a circuit directly from the circuit diagram, and it's easy to make mistakes or lose track of what you have done. However, designing your board layout with DIY Layout Creator can make building the circuit a lot easier, as you can see exactly where each wire and component leg should be placed, and you can also reuse or adapt your designs for other projects. You can, of course, draw your layout by hand on some paper, but you may find it easier to use DIY Layout Creator, as it produces clear, easy to read diagrams which you can reuse or print. So, if you haven't already installed DIY Layout Creator, head over to GitHub where you can download it. I've provided a link in the description to the application's download page. Once you've downloaded it, you'll need to double-click on the file to install the program. Here we have the DIYFever.com website, and from here you can see there is a link to the download page. So if we click that, it brings us to GitHub, and you can see the latest version here at the time of this video is version 4.37.0. You may find when you're watching the video that there will be a newer version. There's also the Mac version and the Windows version, so download whichever one you need for your particular computer. So when the program loads up, you'll be presented with this screen, and this large section here is where your drawing is going to go, and then on the left hand side we have all the different kinds of components you might want to put into the drawing. So for this video we're interested in drawing circuits that are built on breadboard. So if we look here on the boards menu on the left hand side, we can see we have blank board, breadboard, Eurorack board, eyelet board, Marshall styles, Vero board, lots of different types of boards. But the one we want is breadboard, so I'm just going to click that, and then this allows me to place a breadboard on the drawing area. Now, how you work on your breadboard is up to you. I personally like to work on them horizontally, so I'm just going to right click on the breadboard, and then I'm going to go transform selection and rotate counterclockwise. Now, if you're not familiar with how breadboards work, I'll just give a quick overview on how they are used. Essentially, a breadboard is made of plastic and has lots and lots of little holes in it. And these little holes are used to connect different devices together by placing the pins or legs from the devices into the holes. Typically, these lines that are used at the top and bottom are used to provide power and ground for your main circuit. And then the components for your circuit will go into the central area. So in the central area, we then have connectors that are running vertically this time. Okay, so they go from 1 all the way down to the number 5 here. Okay, and then we have the same again, going from here to here. But we have a gap in the middle where there's no connectivity. Okay, so this column here, if you want to call it, of holes is not connected to this column. But all the holes on that particular column are connected together, and these run all the way across the board. So, at any point on the board, you can have these and they're connected together. They're not connected to the ones beside them though. Okay, so if you had a column here like this red one here is not connected to this blue one. So if we wanted to put complex components into our board, such as, say, for example, a chip, we could place it like this, and I'm going to have to rotate it. We just go to transform and then rotate. So we can place a chip into our board like this, right? And then anything that we place into these columns will be connected to the individual pins of the chip. If, for example, I wanted to connect power and ground to this chip, normally what I would do is I would get jumper wire and I would connect pin 4 to ground. So I would connect a piece of wire in here and then bring it down to this particular line here, because this is what would normally be the ground line. And then if I wanted to connect my power connector, I would usually connect it. Depends on the chip, of course, but a lot of these chips, power connectors, are fairly straightforward. So this one here would typically be the power connector, and I could bring it then up to this point here. Now, how do I know that's power? Well, usually the one with the red line next to it is the one you use for your power, and the one with the blue line next to it is the one you use for ground. Now, of course, you don't actually see the lines on the breadboard, so I'm just going to delete them. Okay, so these horizontal lines here, you don't normally see them because there's actually a copper or steel conductor that runs underneath these holes that actually connects them together. So the conductors are not shown, but they are there. I was just drawing those lines to make it easier for you to see. So the lines you do see will be wherever you put a wire into your board. Okay, so we would have, if we were going to connect, say, a battery to our board, we would use hookup wire, and then we would just click on the hookup wire option and then place it on the end of the board like that. So that shows the power wire from your battery, and the power will run along this particular horizontal row here, and then down through this wire and into our chip. The same goes for your ground. So we would also connect a wire to ground. This time I'm connecting it to the one closest to the blue line. And so this would provide ground, and you can see here the ground travels along here and then to pin number 4 on the chip. So let's have a look at a simple example of a circuit to see how it works. Okay, so in this example we just have a simple 9-volt battery. We have a power line coming out of the positive lead of the battery, going into a resistor, and then traveling through the resistor into the positive lead of an LED, and then back out through the negative lead into the negative terminal of the battery. So if we wanted to put this circuit on a breadboard, we would need to do the following. Okay, so I've just brought in the circuit here so you can see it, and I'm just going to move this over a little bit to give us more room. And what we're going to do is we're going to remove this chip, and we're going to put in an LED and a resistor instead. So I'm just going to remove these little lines here because we don't actually normally see those. And what I'm going to leave here are my power lines, but normally it would be a good idea to color these correctly. So to change the color of the hookup wire here, just double click on it, and then you can select your color. So I'm just going to pick red. Okay, and this one then I'm going to pick, and I'm going to change that to black. So double click it, click here, and select black. Now it only changes color once you move your mouse away from it. So there we have our red wire and our black wire. Okay, and then we have power coming along here, and we can take a connection from anywhere along this point. So just for a change, I'm going to delete this one here, and I'm going to just put one in somewhere else. So I'm going to just click on the jumper and then travel along here. Maybe this point will be good, and I'm going to connect it to that column there. And you can see they have numbers on them as well, so it's easier for you to keep track. So next I'm going to get the resistor. So resistors are listed under passive components, and so what we need to do is just pick a resistor and we can pop it into our circuit. So just going to click here, and then I'm going to click here. Okay, and this is drawn a resistor for us, but it's a little bit big, so I'm going to just change it. I'm going to right click on it, and I'm going to go edit selection, and I'm going to change it to 1/4 of an inch instead. Click OK, and now it's a little bit smaller. And we can also do things like this. We can apply a variant. So type of ones I often tend to use are 1/4 watt carbon film, so I'm going to select that type. And now we can see it's kind of typical shape of one of those types of resistors. But it's a little bit too long. I just want to change the length of it a bit. So I'm going to put it there. Okay, so now we have power comes in, travels along this row here, down through this column, into the pin of the resistor, across that gap where there's no conductors, into this point here. So next I need to have my LED. So let's put that in next. So LEDs are under semiconductors. So if we just pick LED here, and I'm just going to put it here, and I'm going to make it go across the way. Okay, so when I move the mouse, you can see the leads of the LED will stretch out to match where you want to put it. But because they usually have pins going straight down, I'm just going to click it there. Okay, and so what this is showing us is we have our LED, and the flat side of it, if I just zoom in, you can see the flat side of it, which is the negative side, is over here. And the 2 pins are going into a hole each. So next, what we need to do is connect the LED to ground. So I'm just going to move this over a little bit so we can see what's going on. And what we want to do is connect the LED to ground. So just want to click on jumper lead again. And we could connect it this way. So what we have here is this negative lead of the LED is connected into this column. Okay, so any one of these holes here will connect to it. So we could just click here and then drag straight down to there, and that would be that connected. But if you prefer, what you can do is you can click on this and just drag it over this way, like that, and then put in another lead that runs across there like that. So if we zoom out, you'll be able to see the whole board, and we can just have a look at the connections. Right, so our power comes in, positive lead, goes along through here, down this column here, through the resistor, down into the first lead of the diode, then back at the negative lead or cathode, and then across. So we're jumping from this column to this column here. Okay, that's why we have a lead. And then because this column is also connected to ground here, our circuit is now complete. I suppose technically it's not complete unless we have a battery in there. So let's do that. Let's put in a battery. So for batteries, we need to look under different types of objects, and usually you'll find it in somewhere like miscellaneous or electromechanical. Yes, under electromechanical we have 9-volt battery clip. So I'm just going to put this here, and then what we can do is we can drag our leads. They use Bezier curves. Okay, and we can drag them and put them where we want. So I'm just going to drag this one up. So you can drag the points like this and then they'll snap on. And then you can use these to kind of manipulate the curve itself. Okay, so that looks better. Okay, and this represents a 9-volt battery connector. Okay, that last circuit wasn't too complicated, but what about something like this? There's a hell of a lot more things than this, and so this might look a bit scary at first, but once you get the hang of it, it's actually not too bad. Initially, of course, these chips don't look the same as the chips that we were using a minute ago, but the only reason they're drawn like this is to make it easier to draw the diagram. The pins are actually not necessarily located where they are shown here, and we'll see in a minute how to deal with that. Okay, so I've just started a new diagram, and what I'm going to do next is I'm going to select board again. So we're going to select breadboard. But for this one, we're going to need a bigger board. So I'm just going to click this here first to put it in place. Then I'm going to transform selection and then rotate counterclockwise. Now some of you may have preferences. Some of you may like to have the red on top and the blue on the bottom. It doesn't really matter though, as long as you're consistent. And so once we have our board, to make it a bigger version, we can just double click it and then we can select size and change that from half to full. And click OK. Alright, so once we have our board in place, you can see it's quite big. Alright, so I'm just going to zoom out a little, and then we're going to just move it up like this. Okay, so this board is twice the size. Now, but sometimes with these boards, not with this particular one, but sometimes you'll find that the rows along the top and bottom are actually separated. So in the middle, you may have to make a little join to connect one side of the board to the other. So in this example, I'm actually going to do that, even though it may not be the case with the particular board you're working with. So let's just bring in our circuit. Okay, and then we're going to use that to work from. Okay, so I'm just going to move this a little bit. And the first thing I like to do is I like to put in the power and ground lines. Okay, so let's do that now. So the first wire is going to be connected into the top here, and that's going to be our ground this time. And the next one then is going to be right next to that, and that's going to be our power. So just going to change their colors. So this one is going to be red, and the other one is going to be black. So just double click it, select black. Okay, so here are two leads coming in. Now I could have put the red lead at the top here and just brought a black lead down this way, but sometimes it's handy to have connections on both the top and bottom, and we're going to do that in just a minute. So as I was saying, some of these boards may be separated in the middle, so I'm just going to bring a wire from here to here and another wire from here to here, and these are going to correspond to just connect the two sides together. So this one, I'll just make this red, and this one black. Okay, so we're going to continue on, and what we're going to do is we're going to use these power lines to connect to these ones as well, and that way, depending on where our components are located, it may be easier to connect them either up or down. I'll just quickly draw on the next few bits to save time. If you want to edit more than one item at a time, if you hold down Control as you click each item, you'll have them all selected together, and then you can edit whatever parameters you want. So next, what I like to do is I like to pick the more complicated components and try and put them in, because it'll be harder to move them later on. So what I'm going to do is I'm going to select the two chips and put them into the board now. So to do that, we go to semiconductors here on the left hand side, pick a dual inline package integrated circuit, click one here, and we'll click it again and put another one over here. Now obviously they're the wrong way around, so we need to rotate them. So I'm just going to transform selection and rotate counterclockwise. Same with this one, transform selection, rotate counterclockwise. So this one here on the left is going to be the 555 timer. So I'm going to edit that. So edit selection, and then under name, I'm just going to put in 555 timer. Click OK, and then this one here is going to be the 4017 counter. Now we need to go to edit selection, but there's a problem. This chip here only has 8 pins and a 4017 has 16. So all we have to do is go to pins and then select the drop down and choose 16. Then we can put in the name 4017 counter. Click OK. All right, so I'm just going to position it now. I'm just going to move it slightly over here, and I'm just going to move this one so it's just about there. Next, I'm going to put in the 0.1 microfarad capacitor because it's a fairly easy component to start with. So to do that, we need to go to passive devices, and then we can pick different types of capacitors here. So I'm just going to pick film capacitor, and then I'm going to place it into about here. So just click and stretch it across the gap there. Now this is a little bit big, so I'm going to right click it and go edit selection, and I'm going to change the size to 1/4 inch as well, because these are often quite small. Now we can also put in the value here if we want. So I'm going to put in, select microfarads, and then put in 0.1, and voltage, I'm just going to pick volts, and I'm going to put in 16 volts. Click OK, and there we go, it's put in. Now of course it's currently not connected to anything, so we need to connect it. So I'm just going to get the connectivity and go to jumper, and then select this column and just connect this to power. So that goes straight up here, and then we're going to connect this one to ground. So click here and here, and then of course don't forget to change the colors to red You don't have to do this in this particular case, but it is easier to follow sometimes when you do this. There we go. That's that done. You may find it handy with large complex diagrams to be able to actually insert the circuit diagram image into your layout so you can use it to refer to. So what I'm going to do is I'm going to remove my picture-in-picture version, and instead I'll show you how to import the image. So in this case, what you want to do is go to miscellaneous, and from miscellaneous just select image. Then you can click anywhere in your diagram, click on the image itself, and then you can choose click to load image file. So I just happen to have it here, and I'm going to open it up. And you can leave the scale the same size, or you can shrink it if you want. I'm just going to make it a little bit smaller, maybe about 80%, and click OK. And so there is the circuit diagram, but we're trying to make a breadboard diagram. So I just keep this here for handy reference. Next, we're going to put in the 2K2, the 47K, and the 1 microfarad capacitor into our circuit. So let's have a look at how to do this. I'm going to scroll up a little bit so we can see both things. And then I'm going to zoom in to the 555 just to have a look at this. So when we're dealing with chips, there's a little notch on one side of the chip. And pin 1 starts right here. Then we have pin 2, pin 3, pin 4, pin 5, pin 6, pin 7, and pin 8. So it starts at the notch and then works anti-clockwise around. Same with this 4017 over here. We have pin 1 here, then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 over here. So let's just zoom it back out a little bit and have a look at our diagram again. So we have 2K2 resistor connected from power into pin 7. So let's get a resistor, and we find them under passive. So we get a resistor, and we're going to connect it from pin 7, which is here, up to power, which is here. So let's take that power one and then get a resistor and connect it to here, and then I'm going to edit the resistor, and we're going to choose 0.25 for our size, and the value in this case is 2K2. So if we select K and then put 2.2, and power rating we can put 2 watts, and we can put 0.25. Click OK. And you can see now that it's actually put in the stripes for the type of resistor that it is. I'm just going to change the variant again. So apply variant and select 1/4 watt carbon film. Again, that's that style there. But because I've changed it, I now have to change those values again. Okay, so the value is in K and it's 2.2. Then we click OK. And it's named it R1, and you can see the color codes are put in there. Okay, so I'm just going to move him down one more. Okay, so that he fits in there nicely, and he is connected. Actually, I'll go back. He's connected into pin 7. Okay, so scrolling down, we can see now that we have the 47K resistor, and that's connected from pin 7 as well to pin 6 or 2, because 6 and 2 are actually connected together. So let's connect pin 6 and 2 together first, and then we can put in our resistor. So if we look at our chip here, we have pin 6 is this one here, and pin 2 is this one here. So we need to connect them together. So again, we go for our little jumpers, and we're going to connect this one. And I'm going to bring this across to about here. And then I'm going to get another little jumper and connect it to here. And then I'm going to bring another jumper across, and we're going to connect it then to pin 2. So here's pin 2. I'm just going to bring it down maybe about here and connect it to there. So what we've done is we've connected pin 2 here along this way up through here and over to pin 6. So pin 6 and 2 are now connected together. Next we want to put in the 47K resistors. So to do that, we'll just pick our resistors from here and we're going to draw it. So it has to connect to this resistor up here, and it also has to connect to where pin 6 and 2 meet. So pin 6 and pin 2 meet on this particular column here. So if we connect from here over to this point, we're actually connecting it. So we just need to change this, make it 0.25, and change the power rating to 1/4 watt, and then change the value to K and put in 47. Click OK. And then I'm just going to change the variant to 1/4 watt carbon film. Again, I forgot. I have to go and change the value. So we just put in the value of 47K. There we go. Okay, so that now looks like this. So we're making good progress. Just a couple more things to connect on this particular chip. So if we scroll down, we can have a look. So we have pin 7, pin 6, pin 2 connected up, but we have to connect pins 8 and 4 up to power and pin 1 down to ground. So that's pretty easy to do. So let's do it. So pin 8 and 4 up to power. So we're going to get our jumper again. And pin 4 is this one here. So pin 4, we can connect to power by bringing it down to here. So if we click here and just here, we've now connected pin 4 to the power line. And pin 8 also has to be connected to power. So pin 8 is this one here. So if we just take a wire from this point and bring it to here, that's done. Now I'm just going to change the color as well, because I find it easier if I set power to red and ground to black. Okay, there we go. Whoops, that one's not supposed to be black. It's connected to power. So I'll just make it back into red. Okay, so now we need to connect the ground wire. So the ground wire is pin 1. So pin 1 is this first one here. So just need to connect this column to the ground one, which is this one, and change the color of this guy to black. Now I almost forgot, we have to connect the capacitor, the 1 microfarad capacitor that we have here. That has to be connected to pin 2 as well, and also to ground. So let's do that next. So first of all, we want to look for capacitors, and this time it's an electrolytic capacitor. Okay, so we select electrolytic, and where I'm going to connect that to is somewhere around here. So here's pin 2, right? And so if we look, this electrolytic capacitor has to be connected to pin 2. So pin 2 is here, and it meets up with this column here. So if we take our electrolytic capacitor and just click here, and then connect it to the ground line here, that's it. And when you see the capacitor, it has a sort of a line here to show you the negative side. It's very important with these guys to make sure they're connected the right way around. If they're connected the wrong way around, they can occasionally blow up. So it's very good to, very important to connect them the right way around. So there's just one more wire coming out of the 555, and that one is the connection or the output of the 555, which triggers the 4017 counter, and this goes from pin 3 to pin 14. So what we need to do is find pin 3 and pin 14. So pin 3 is right here, and pin 14 is this one here, because we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That's this one. Okay, so to do that, I'm just going to get some jumpers again, and we're going to connect it from here, and we're going to just bring that across to about here. And then we get another jumper, and we bring it up to here, and then another jumper, we can bring it across to pin 14, which is this one. Now, because this wire connects the two chips, I'm just going to change it to a different color just to make it easier to see. So I'm going to click on each piece of wire using Control. If you hold down Control, you can select all three of them together. And then just right click on the last one, go to Edit Selection. I'm just going to change the color to a green of some kind. And it just helps me to kind of understand what that wire is for. Now onto the counter chip. So let's see what's connected. So we have pin 16 is connected to power. Pin 13 is connected to ground. Pins 9 and 15 are connected together, and pin 8 is connected to ground. So let's try doing those ones first. So pin 16 is connected to power. So to do that, just get a jumper. Pin 16 is the last one here, so we just have to click, put in our power lead right there, change its color. That's that one done. So pin 8 is connected to ground. So click here and just click there like that. Change the color to black. And that's that one done. And then we also have pin 13 connected to ground. So jump over that one. So this is 16, 15, 14, 13. So just connect this. Here like that. Change the color. And that's that done. Then we have pin 9 and 15 connected together. So just a jumper, and then pin 9 is this one here. So I'll just go across this way, and then pin 15 is the second last one from the edge. And that's that done as well. So at this stage, our 4017 counter is powered up and is receiving an input from the 555 timer. But we still need to connect up all of these LEDs. And these LEDs are going to light up in sequence, one after the other. And then when it gets to the end, it's going to reset, and it's going to go back to the first one, and they're going to light up in order again. So once we figure out how we can set up one of these LEDs, we can just kind of continue the same pattern across for each one of them. Okay, so before we connect up the LEDs, it's worth having a look at how the outputs work on the 4017, as this will make it easier to understand the way we're going to do the layout. When the 4017 receives an input on pin 14, the first thing it's going to do is output a high to pin 3. Then it's going to go to pin 2, and then it's going to turn on pin 4, then it's going to turn on pin 7, then pin 10, then pin 1, then pin 5, and then pin 6. And at that point it's counted up to 8. And we have 8 LEDs, so that's what we want to do. We want to turn on those 8 LEDs in sequence. Then once it receives another input, it outputs to pin 9, and then that sends a reset signal into pin 15. And what happens is, it starts all over again. So unfortunately, it's not quite as simple as just connecting our LEDs up to pin 1, 2, 3, 4, 5, 6, 7, 8 on the 4017 counter. But that's okay, I guess. It just makes it a little bit more challenging. Let's put in the first LED. So before we connect our LED, I'm just going to put in a resistor. It's always good to protect your LEDs with a resistor. So I'm going to position the first one about here, and we're going to put it up to here. I'm just going to change the type and apply a variant to quarter watt carbon film, and then we're going to change the value to 330 ohms. And the power rating to quarter watt. Okay, so that's that in place. Next, we're going to place the LED. So we'll just pick one from here. And then I'm just going to position it across the top here. Okay, so what's going to happen is we're going to have an output coming from, if we look at this diagram here, we can see pin 3 is the first LED. So we'll be connecting from pin 3 over to this resistor, up through our LED, and then back down to ground. So let's connect in the ground wire. So the ground wire is going to come from here. It's going to go across to bridge that gap. And then it is going to continue on down to ground like that. I'm just going to change its color. Black. And same for this wire. Okay. Next we have to connect from pin 3 on our 4017 to our resistor here. So here is pin 3. So I'm just going to go down to the bottom here, and then I'm going to drag across to this column here. And then I'm going to change the color because I like to keep all of them separate colors. It makes it easier to keep track of where they're going. So it's going to be purple. Okay, so that's our first LED connected up. It comes out of pin 3 here, goes through the resistor, through the diode, the light emitting diode, and then down to ground. So what I'm going to do is speed it up while I put in the other ones. The duplicate command can be really useful there. You just right click on the component and select duplicate, and then you get an exact copy. These last few wires can be a little bit tricky, so I'm just going to use a different color for each one so it's easier to see exactly where they're connected to. The second LED is connected to pin 2. So here's our second LED, and here is pin 2. So I'm just going to change that to a different color. Pick it kind of a turquoise. Okay. Let's just move the picture down a little bit so we can see what we're doing. Okay, so the next one we want to connect up is the third LED, and that is connected to pin 4. So we'll get a jumper and connect it to pin 4, which is this one. Just going to make this a green color. Now the fourth LED has to be connected to pin 7. So this is the fourth one, and pin 7 is this one here. Just going to make this a yellow color. The fifth LED is connected to pin 10. So this is number 5, and we're going to connect across over here to, that's 9, and then pin 10. So we make this some other random color. I'm going to pick a mustardy green. So the 6th LED is connected to pin 1. So that's this one here, all the way over to pin 1. I'm just going to leave that as the color it is. The 7th LED is connected to pin 5, so I'll just connect this up here. That's that one, and I'm just going to make that orange. And finally, the 8th LED is connected to pin 6. And I'm just going to change the color of that to pink. Okay, so that's it. We finally managed to wire up all our LEDs. There are just 2 last components to go into the circuit, and these are the switch and the 9-volt battery connector. So I'm just going to zoom out a bit, and I want to make some room in my drawing for the battery over on the right hand side along with the switch. So what I'm going to do is I'm going to press Control A on my keyboard to select everything, and then I can just drag the whole thing over to the left by just clicking on it. So this just gives more room in the drawing. Once I'm happy with where it is, I can just click away from the components, and it unselects everything. So I need a switch, and under electromechanical items there are switches, but I don't really have the kind of one that I want to use. There is a mini toggle switch which we could use, which looks like this, but I'm not going to use that. I'm actually going to draw one instead. So to draw one, what we need to do is first of all check that under config that we have our grid set to show grid, and then also snap set to grid. Then what we're going to do is we're going to go to shapes, and we're going to select rectangle. So when we select a rectangle, we can place it onto our drawing. So I'm going to zoom in a bit more here so we can see the grid squares more clearly. And then I'm going to just click the shape and reshape it. So I'm going to make my switch about this size. Then I'm going to change the color of that to kind of a gray color, dark gray. And then I'm going to put in another piece. So go rectangle again. This time make it smaller. And we can make it about that size, and then I'm going to convert that to black in color. So this is going to be a slider switch. And we need 2 pins for the switch, so select rectangle again. This time it's going to be a smaller rectangle. And what I want to do is I want these rectangles to actually go over the grid lines. So what I'm going to do is I'm going to turn off the grid, or at least turn off snap to grid. So just set that to none. And I'm going to zoom in a bit more and a bit more. And then I can move this so it is halfway across the grid square. And I'm going to do the same for another one. So I'm just going to turn the grid back on for a second, snap to grid. And I'm going to draw another rectangle. And then I'm going to turn off the snap again. Just move this up here. And then what I'm going to do is change the color of these. So I'm just going to hold down Control and click the other leg. Then I'm going to right click, select Edit Selection, and pick a color. So light gray color. Okay. So we need to add some connector points onto those legs. So what we do is we go up to Connectivity and we go to Dot. And from here we can drag dots over to the center points of each of the legs. And this is what we'll be able to connect the wires to once we're finished making the switch. So pick a label, double click the text, and we're just going to call this on-off switch. And I'm just going to do SW for short. And the color is going to be, actually black is probably fine, so we'll go with that. Okay, and it's not fitting perfectly, so I'm just going to turn off this again. And that way I can reposition it exactly the way I want it. Now, once we have the switch made up, you can then select it all. Then if you right click on the object, you can go Save as Building Block. And what we get here is a name, so I'm just going to call it Slider Switch. Click OK. And now if we look up here on the top left, we will see that slider switch comes up under building blocks. So we'll be able to reuse this again in the future. So if I want to bring in a slider switch, I can click here, and now I have a slider switch. So I'm just going to delete that again. And I'm going to put the switch properly into the diagram now. So let's zoom out a bit. And I'm just going to select it and then move it over here. So what I want to do is just connect the red wire to one of the dots that I placed earlier. And the black wire can continue to the battery connector. So to do that, we're just going to get our battery connector. So that's under electromechanical. Here's our battery clip. And we can take that black wire and bring it straight over here. And then we can just get some more hookup wire. And we can connect it from here up to the battery clip. There we go, we've done it. We are now finished. So let's just zoom out and look at our full circuit. If you need to rescale the image, you can just double click it and you can choose scale. So I had set it to 48% just to make it a bit smaller there. You may also decide to just delete it once you're finished with it. Once you're finished your drawing, you can take a screenshot if you want, using Windows Shift S to take a picture of the screen, or you can also go to File and Export to PNG. So that'll export it to a PNG file or a PDF. And then you can use those later on for other projects. If you want to be able to reuse your circuit, make sure to save it as well. So here's another look at the finished circuit. As you can see, it's very similar to the diagram we just did. Using the diagram made it a lot easier to build the circuit. As always, thanks for watching, folks. Hopefully this video was of some use to you. If you did like the video, perhaps you might give it an old like and maybe subscribe to the channel. See you next time.